Okay, so what I have here is functions. We're going to talk a lot about functions and relations. Relations are relationships between two numbers, usually an x and a y. And some relations meet the qualifications of being a function as well. So, here's what we're given in our first two examples here. We are given a set of ordered pairs. Do you see that? Yes. We are going to represent those ordered pairs three different ways. We could represent them here in an XY table. An XY table is also known as an input-output table. Why should that make sense to us? Because input is and output is y. So, if I have the point -2, 5, -1, 1, 3, 1, and -1, -2, let's put those in here. -2, 5, -1, 1, 3, 1, and -1, -2. Easy peasy? Okay. How would I represent those as a graph? Plot them, right? So -2, 5 would be left 2 and up 5, right there. -1, 1 would be left 1, up 1. 3, 1 would be 3 to the right and 1 up. And -1, -2 would be the left 1 and then down 2. Does that make sense to you? Does it make sense to you that the table, and the graph are all ways of representing the exact same information? So if I gave you the graph, could you make a table for me? Okay. If I gave you a table, you should be able to write the ordered pairs or do the graph. Then there's finally this thing called a mapping diagram. Have you ever seen a mapping diagram before? Yes? Okay. So over here we're going to put our x values, and over here we're going to put our y values. Or in other words, we're going to put our input and our output. Now we're going to list it kind of the way we list our domain and range. All right? So if I look at my x values, I need to write them in order from least to greatest. What's the smallest x value or the least x value? -2, followed by what? -1, and -1 happens twice. I only need to write it once. And then I have 3. I'm going to do the same thing for my y's. What's the smallest y value? -2, followed by 5. And what I'm going to do is I'm going to start drawing some arrows. You ready? If -2 on the x side goes with 5 on the y side, then I draw an arrow from -2 on the x side to 5 on the y side. That's how I represent that first point. -1 on the x side goes over to +1 on the y side. 3 on the x side also goes to 1 on the y side. And then -1 here goes with -2 there. So we have the same bit of information represented as ordered pairs, as a table, as a graph, and as what's called a mapping diagram. We okay so far? Yeah. You try the same thing with these points right here. Write them in the table, the graph, and the mapping diagram. You take a minute and do number 2. Do you notice anything interesting about this one? The y's are all the same, aren't they? Okay. Does that mean I can't do one of these things? No, I can still do all these things, right? I can still graph, let's see, over 5, up 3, over 4 up 3, 3, 3, 2, 3, 1, 3. And here, if I were to write my x values and my y values, x values in order would be 1, 2, 3, 4, 5. And my y values, there's only one. So I just have a bunch of arrows going to 3. Funky looking mapping diagram. But if I gave you a mapping diagram, you need to be able to pull out the coordinate points from it. You need to be able to graph it, or you need to be able to make a table from it. Okay? You need to be very fluent with those guys. All right. Domain and range. We're going to talk domain and range again. By the way, these are relations. This is a relation of these x values to these y values. This is a relation of these x values to this y value. Here's another relation represented as a graph. Is it a continuous graph or a discrete graph? Do I need to pick up my pencil when I'm drawing it? That makes it continuous. Okay? So, if I'm looking at this, this graph distinctly has, let me grab a couple. Oh, I wish I had different colors. I don't, but I'm going to use these just to help. So if I'm looking for the domain of this, okay, I'm looking from left to right, how much could I close this in, close these two people's papers together? How close can I get them without cutting off any of the graph? I can get to right there, correct? This is as far as I can get over on the left side, and on the right side I can come to here. So my domain is whatever this is representing. This is starting at what? 0 and going to 4. So my domain is 0 to 4. And you put your x and your less than or equals to in there. Does that kind of make sense? Y, I'm going to do the same thing, except I'm going to come from the top and the bottom. So bottom, I can come up to here, yeah? And top, I can come down to here. So I'm looking this way. It can go from 0 to 4. So it's same kind of thing, except I can't write it exactly the same. What do I have to change? The x needs to become a y.
Wait, how do you do that?
I just did this.
Oh, but how? Where'd you get the 0 from?
Because when I closed it in, this point right here is at 0, and this right here is at 4. So those are the boundaries, or that's where my papers have to stop, otherwise they'll start cutting off a part of the graph.
Oh.
Okay? Same thing with this way. Y value of 0 up to a y value of 4. Okay? Is this a function? Now, I think we wrote down the definition of a function a couple days ago, and I said a function is a relation where every input has exactly one output. Okay? So what that means is that every x value, or every input, has its own y value. So in other words, I cannot repeat any x values. So in this, let me come back up here. Are any of my x values repeated? Yes. If I have x values repeated, it is not a function. Still meets the requirements of being a relation because it is two numbers that are related to each other. How would I be able to tell from a graph that I have an x value that's repeating? Do I have to turn the graph into a table? Or into points? How could I tell from a graph? If 2 points have the same y or same x value, let's look at those 2 points on the graph. Where is -1, 1? Right here. And -1, -2 is right there. How are those similar?
We're still on the same line.
They are vertically right above each other. So that leads us to this thing called the vertical line test. Have you heard of that before?
No.
Okay. The vertical line test says if you have 2 points that a vertical line would go through, that means you have a repeating domain value and you don't have a function. So if I go back to the example I was on here, is there anywhere that if I were to draw a vertical line through this, that it would hit more than one time? No. What does that mean? Does that mean it's a function or it's not a function?
Yes.
That means yes, it's a function. And my explanation would be passes the vertical line test. Okay. Is, going back, we talked about number 1 not being a function. Is number 2 a function?
No. No.
Are there any x values that are repeated?
No.
No. Y values can repeat all they want to. Whether it's a function or not is dependent on if the x values repeat. Does it pass the vertical line test? Sure does. Each one of those, it's only going to hit it once. So yes, we have a function. Okay. So if I have a list of points, if I only gave you a list of points, how would you determine if it's a function? Check. If I only gave you a list of points, I didn't give you a graph or anything. Just check to see are any x values repeating, right? If I only gave you a table, what would you check for? Are there any x values repeating? If I only gave you a graph, what would you do? Check with the vertical line test. How could I check from a mapping diagram? Check if one of your x values goes to more than one y value. Do you see how this one has 2 arrows from it? That means it's repeating. You can have as many arrows as you want to going to the same number over here, but in your domain, if you have more than one arrow coming from somewhere, that means it's not a function. So let's look at number 4. Is number 4 a function? No. Why not? 8 doesn't just go to 2 different ones. It looks like it goes to 1, 2, 3, right? So 8 repeats. And 9 repeats. So I have domain values that repeat. And that makes it not a function. By the way, you notice this one wasn't labeled x and y at the top. It's always assumed that the first one is x and the second one is y. Is this discrete or continuous? Discrete. I don't know if it's connected or not. They don't tell me any information that would make it connected. So when I list my domain, I have to use my squiggle lines. What's my domain? 8 and 9. My range, I actually don't care for how they have this listed, but if I write this in order, what would it be? -9, -6, -4, -3. Okay? What's my domain on number 5? 0, 1, 2. What's my range on number 5? 4, 5, 6, 7, 8. Is this a function? Yes or no?
No.
I have a repeat here. And I have a repeat here. So why is it not a function? Domain values repeat. So each input doesn't have one output. This input value actually has two output values. It has 4 and it has 7. Okay? So if I plotted the point 1, 4 and 1, 7, it would not pass the vertical line test if I looked at it that way. Okay? So from this front side, you need to be able to represent things multiple ways. You need to be able to determine from any of those ways what's the domain, what's the range, is it a function, and then tell me why it is or why it isn't. Okay? All right, let's turn to the back. All right, so here I have a set of ordered pairs. What's my domain for number 6? 0, 3, 5. What's my range? -1 and 1. Is this a function? Do my domain values repeat? So it's a function. Range values can repeat as much as they want. It's the domain values that cannot repeat. Number 7. What's my domain? In order. -1. Like that. What's my range? -4, 2, 4, 5. Is this a function?
No.
Why not? What repeats?
3.
3, the domain value of 3 repeats. Okay. All right, state whether each mapping diagram shows a function. If not, tell me what's repeating. Is number 8 a function?
No.
Domain value what repeats? Domain value 9. It repeats, it has 2 outputs. Number 9.
Yes.
Is that a function?
Yes.
Why?
Because nothing repeats.
No domain repeats. I should say no domain value repeats, but all right, you answer 10 and 11. Is number 10 a function?
Yes.
Why? Is number 11 a function? Why? Yeah, that's probably right. Value 5 has 3 outputs. What are the outputs of 5? 2, 6, and 10. Now, number 10 is kind of interesting to me. What's the domain of number 10? 1, 3, 5, 7, 9. What's the range? 2, 4, 6, 8, 10. If you listed those as ordered pairs, what numbers would you not see? 2, 4, 8, and 10 are not included in any of those. So why are they a part of the range if they're not even included? Think about it as if it was a survey. Let's say you were taking a survey. Student number 1 was asked, what's their favorite number? 2, 4, 6, or 8? Sorry, 2, 4, 6, 8, or 10. Those are all options of outputs, but all of them just happen to choose the same one. That would be a circumstance like that. Okay? All right. A club's president kept track of membership over its first 7 years. Use her graph to solve these problems. What is the range in the graph? Well, I could list the points, couldn't I?
Yeah.
Or I could just identify the what? Y values. And if I want to go in order, I'm going to use my little paper and I'm just going to start sliding up. So the first point that I have to stop at is at what? 30. Then what? 40. Then what? 50. And then what? 60. And it looks like that covers all of them, correct? So again, range, you're always going up and down. When it asks for the domain, what am I going to do? Left to right. So my first point is at 1. Next one is at 2. Next one is at 3. And then 4, 5, 6, 7. That's it, right? Oops. That's what my domain looks like. Is it a function? Does it pass the vertical line test? There's no 2 points that are directly above each other, right? So yes, it is a function because it passes the vertical line test. And again, the vertical line test is just the way you can check for those repeated domain values if you're given a graph. Okay? All right, 15, 16, and 17. These ones are super fast. These are just vertical line test. Is number 15 a function? Does it pass the vertical line test? Yes. Is B a function? No, because there's a lot of places I could draw a vertical line and it's going to hit it more than once. What about 16A? Because if I drew a vertical line, it hits it twice. B? Lots of places it'll hit it twice, right? 17A. If I use the y-axis as my vertical line, hits it all over the place there, right? What if that one was turned on its side? What if the graph looked like this, and this was my y-axis, and this would be my x-axis? Would that be a function? Okay. And then letter B. This is an interesting one. So letter B, the graph goes from here over, and then there's an open circle, which means that that part right here, this point, isn't a part of the graph. And this point right here is not a part of the graph. So does it pass the vertical line test?
Yes.
Because the only place that it looks like it could overlap, those open holes mean that it doesn't. So yes, it is a function. Okay, so what's tonight's homework like? Identifying, is something a function, yes or no? Identifying domain and range, and potentially showing me multiple representations of something. Okay? All right, your homework is on Google Classroom. It's the section 3.2 in the textbook, numbers 1 through 22. Happy studying.